Yes. Yes. So is my screen visible? Okay.
Yes, sir.
Yeah. So this is our last class on this course, Strength of Materials. Okay. And today we will be seeing about, as I said, torsion of shafts, columns, and then cylinders and spheres. Okay. So starting with a numerical problem on torsion of shafts, like a solid shaft which transmits 300 kilowatt at 100 rpm is given. If the shear stress is not to exceed 80 megapascal, what should be the diameter of shaft? And if this shaft is to be replaced by a hollow shaft whose internal diameter is 0.6 times the outer diameter, determine the size and weight percentage saving in weight and the maximum stress. I mean the maximum stress being the same. Okay. So can you solve this?
Try.
Yeah. So first, what you will find out? Given is tau max equals to 80 Newton per mm square. Okay, and power is equals to,
What is the torque given?
yeah,
From power we could calculate the torque.
yes, 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 yeah. So from power, if you are calculating the torque, it is like 2 pi n t by 60, right?
Yes, sir.
Yeah. So from this you can calculate the torque. What is the value of torque you are getting?
Solving
Yeah,
calculator. 35,80981.
35,000. I don't think so. See, it is 60 into 300 divided by 2
Twice
pi,
580.
yeah, into 100, right? So if you are
35,000.
100 is the rpm. So when on solving this, you will get the answer in kilonewton meter.
Okay,
So
okay, okay, okay.
yeah. So is it 28.65? Are you getting this answer? Everybody is getting this answer?
Yes, sir.
Okay. Then based on this, what we want to find out then? First we have to find out the diameter of the solid shaft, okay, and then we have to find out the diameter of the hollow shaft if this solid shaft is replaced by a hollow shaft. Okay, so the first case is to find out the dia of solid shaft. So t equals to, I mean t by j equals to tau by r, right? Yeah, so if you are replacing t equals to tau into j by r, so j by r is nothing but the polar modulus, right? So t tau into zp. Yeah, so what will
From
be
here
the,
we could do.
yes, pi by 16 dq. So from this you can find out what will be the value of d. So d is 28.65 kilonewton is there, right? So into 10 to the power of 3, which is equals to tau is 80 megapascal, I mean Newton per mm square, into pi by 16 into dq. So if you solve this, you will get the value of d.
For calculating this, how is the percentage taken? Saving in weight means
Percentage saving in weight means like we have to find out what percentage of what percentage saving in weight. For example, weight is nothing but mass into volume into density, right? I mean mass into gravity, mass into gravity. Okay, so gravity is constant, so mass is equals to density into volume, right? So density also, these two are of made of same material, so density also is constant, so only variation is obtained in the volume. So what is the percentage saving in volume will be the percentage saving in weight. Okay, so percentage saving in volume is nothing but area into length. So here length also remains the same. So only saving you have to obtain is like percentage saving in area. So that is the last thing you have to calculate. Okay.
12.21, sir. Diameter.
How much?
12.21 mm.
12.21 mm. Is anyone getting any other answer? Any other answer? I mean, here you have to take care of it is in meter also, so you have to take care of into 10 to the power of 3, which is mm. Okay. So you should be getting 122.1.
18 mm.
Yes. Okay. 122.18 mm is the diameter of the solid shaft. Now what you will do the second case, okay, if the diameter of the I mean if the solid shaft is replaced by a hollow shaft, okay. So for hollow shaft case, di is equals to 0.6 times d naught, which is the inner diameter is 0.6 times the outer diameter. Okay, for this you have to find out what is the uh, diameter, outer diameter. Okay, so again going by the formula, T by J equals to tau by R, which is nothing but T equals to tau max into ZP. So tau max is the same. Okay, so T is nothing but 28.65 into 10 to the power of 6 equals to tau max is 80 into what will be the value of ZP here, pi by 32 into d naught power 4 minus di power 4 all divided by d naught by 2, right? So it will become 28.65 into 10 to the power of 6 equals to 80 into pi by 16 d naught into d naught power 4 minus di power 4. Okay, so if I am substituting the value of di power 4 in terms of d naught, it will be 80 into pi by 16 d naught power 4 minus 0.6 d naught power 4 divided by d naught. Okay, this is 80. So at last what I will be getting? Anyone? 28.65 into 10 to the power of 6 equals to 80 into pi by 16 into, this is like d naught power 4 minus 0.6, the whole power 4 is nothing but 0.6 the whole power 4 should be 0.1296 d naught power 4 divided by d naught power 4. Okay, so is it fine? So can you tell what is the value of d naught from here?
Is it 127?
Yes, yes, yes,
0.90.
yes, it is 127.96 mm. Okay, from this you can calculate di equals to 0.6 times of d naught, okay, which is 76.
76.
Yes, mm. Okay. So the dimensions of the hollow shaft also we have calculated. Now the third part is, what is the percentage saving in weight? Percentage saving in weight. Percentage saving in weight is calculated as I said, like it actually boils down to the saving in the cross sectional area. Okay. So what is the cross sectional area of solid shaft? Sorry. Solid shaft minus cross sectional area of hollow shaft divided by cross sectional area of solid or hollow shaft.
Solid shaft.
Yes, it is solid shaft. Since the reference is solid shaft, okay, from that when we are going to hollow shaft, we are getting a reduction in the weight. Okay, so can you find out what is this? What is the value? Okay, I need a new slide then.
सर एक बार के लिए प्रीवियस पेज दिखाइएगा.
Yeah, 1 minute. Yes, this, yeah.
Okay sir, thank you sir.
Yeah. So cross sectional area of percentage saving
70.2%.
70.2%.
70.
70.
Yes sir.
Then I think you have done it the other way. I think so. It should be 31.39% of weight is saved. What we have done, cross section of solid shaft minus cross section of hollow shaft divided by cross section of solid shaft, right?
Sorry sir, वो गलत कर दिया. Okay sir, 30%
Yeah.
आ रहा है.
Okay. Pi by 4 d square minus pi by 4 d naught square minus di square divided by pi by 4 d square. Okay. So if all the pi by 4s will get cancelled, okay. So it will come to, I mean, d square minus d naught square minus di square divided by d square. So directly you can substitute the answer here. It is 122. Yeah. And this is 127.96, right? The whole square.
Into 1 minus 0.36.
Yeah. 26.78 the whole square divided by 122 point. So on solving this, how much value you are getting?
29.8%.
29.8%. Okay. So the textbook answer is more or less equal to what you have given. Okay. The textbook answer is 39.39%. Okay. Fine.
Right.
Yeah.
And this
Yes.
problem, this problem last statement in the question.
Yes. Maximum stress being the same. You want that? Your voice is not clearly audible.
But practically, that is not same.
What?
It is assumption or practically also same, sir.
Okay, see, practically also in some cases it can be the same. For example, let's say we are designing a solid shaft, okay, but due to some constraints in weight, like I want to design the same shaft but with a hollow size. Okay, so in that case we will keep the maximum stress as the constant. Okay, and also like if the shaft is to be made of same material, like we can't go for a change in material, then also we need to keep the maximum stress as the constant. Okay.
Okay, sir.
Yeah. So now let's come to shaft in series. Okay. So for shaft in series, like what we will be assuming is like there are a lot of shafts. Okay, which is connected to a solid shaft. Like for example, let's take this as the main shaft. Okay, and then there are lot of pulleys which is connected over this main shaft. Okay, and to this pulleys, like it is subjected to some kind of a torque load. Okay, like imagine like it is like a belt drive. So if it is subjected to these kinds of torques, so what will be the diameter of this solid shaft, or what is the angle of twist theta of this solid shaft? So these are the things we are going to. These are the things which are important to us for in terms of designing these kinds of shafts. Okay. So here the condition for this is like the torque which is endued by all these shaft will be the same. Okay. For example, T1 equals to T2 equals to T. Okay. Whereas the angle of twist will be equals to, for example, if this is A, this is B, this is C, then the total angle of twist, okay, from A to C will be equals to theta of AB plus theta of BC. Okay. Is it fine?
Yes, sir.
Yeah. So based on this, like they have given, I'm erasing this diagram. Okay. Based on this, actually they have given a diagram like this. Okay. See, for example, this condition T1 equals to T2 equals to T is valid only for a what to say, a composite shaft, which is like not a composite shaft, means a shaft which is connected to for example a two shaft which is made of, yeah, different diameters and different materials. Okay, so for to this shaft, if I'm applying a like a torsional load, for example T, okay, let's name this member as 1 and let's name this member as 2, and this is A, B, C. Okay, so if this is the case, then it will be like T1 equals to T2 equals to T. Okay, is this fine? Yeah.
Yes.
But in our problem, what they have given is like, okay, here this is an aluminum shaft, okay, with a diameter of 40 mm. Okay, it is subjected to torques as shown here. Like here with double arrow I am giving. Okay, double arrow means it is torque. So it is 800 Newton meter, and then this is point D. Okay, or section D, and at a distance of 2 meter, here it is like 1100 Newton meter. Okay, 1100 Newton meter. And for section B, it is, this is section B, this is section C, this is 2 meter, this is 3 meter, and this is 2 meter, and this is section A. Okay, and this is 600 meter Newton meter. Okay, and this one is 900 Newton meter. Okay, so can you find out what is the total angle of the what you have asked to calculate? Determine the relative angle of twist of cross section D with respect to A. Okay, double-headed arrow. So can you find out?
Yes, sir.
Yeah. So what is the torque in section DC or member DC?
800
Yeah. Positive or negative?
positive.
Okay. And what is the torque in section CB?
Minus 300.
Yes. And on section BA?
Positive 600.
600. Yeah. So based on all these values, you have to calculate theta. Okay. So what is the polar moment of inertia here? J pi by 32 d per 4. So d is 40 mm. So whose value is, what is the value of this?
Sir, is the answer 0.43 radian?
0.43. No.
In angle 24 degrees?
I think you are getting double the value.
251.
Huh?
What, sir?
You are getting double the answer.
Okay, sir.
Yeah. What is the value of polar moment of inertia you are getting?
251,
Yes.
327.
Yeah.
Common of 4.
Yeah. So it should be
212.
25.13 into 10 to the power of 4 mm per 4. Okay.
Okay, sir, I had galti se 32 ki 64.
That's what. That's why you are getting double the answer. So after this, we have to calculate what is theta dA. Theta dA is nothing but theta DC plus theta CB plus theta BA. Okay. So how we are going to calculate theta DC? It should be TDC into TL LDC divided by G. G is common and J is also common. Okay. So similarly, it should be TCB into LCB divided by GJ plus TBA into LBA divided by GJ. Okay. So which is equals to, what is TDC here? It is 800 and into Newton meter, right? So in terms of mm, if I'm writing, it should be 10 to the power of 3 and the length is 2000 mm. Okay. And the GJ is constant, so I will write GJ in the denominator. Okay. And this is positive. Okay. And for the CB, whether I should take sign or I should not take sign?
Sir, sign लेना पड़ेगा.
Sign I should take, right?
Yes, sir.
Yeah. So it is minus 300 into 10 to the power of 3 into 3000. And it is positive for section BC, and it is 600 into 10 to the power of 3 into 2000 divided by G. G is how much? 35 gigapascal. So 35 into 10 to the power of 3 megapascal into 25.13 into 10 to the power of 4. Okay. On solving this, what you are getting? Can anyone say what is the angle of twist in radians? Theta dA. Anyone? Someone has solved it, right?
सर वो कॉपी पर लिखना भूल गया था तो दोबारा कैलकुलेट कर रहा हूँ.
Yeah.
0.216.
0.16, yes. So it is 0.216 radians. So if you are converting it to degrees, it should be 12.37 degrees. Okay.
Yes, sir.
Yeah. So for shaft in series, like since here, like it is individually we are applying torques, okay, at this. For example, this is like a pulley, okay, and to this pulley we are subjecting a torque of 1100 newton meter, okay, something like that you can imagine. And here also a pulley is attached, and to this 800 newton I mean 800 newton meter torque is applied, okay. You can imagine like that. Or if they have given a shaft which is like this, okay, two different shafts which are made of same material or different material and having different cross section or different diameter, then and a single torque is applied, then the torque value remains the same for the both the shaft, okay. So for that case it will be T1 equals to T2 equals to T, and the theta AC will be equals to theta AB plus theta BC, where how I can find out theta AB, it will be T into L is LAB divided by GAB into JAB, okay. Similarly T2, which is T, okay, into LBC divided by GBC into JBC, okay. So shaft in series you will be getting like this, or you should approach the problem like this. Fine.
Yes, sir.
Yeah. So now can we see shaft in parallel? So this is a problem based on shaft in parallel, okay. Here they have given a composite shaft of length 2.5 meter is made from steel and aluminum, okay. Composite shaft has 54 mm steel core and 18 mm aluminum jacket around steel core, okay. And if the shear modulus of steel is 80 gigapascal and shear modulus of aluminum is 27 gigapascal, the allowable stress in steel is 60 megapascal and the allowable stress in aluminum is 45 megapascal. Then determine the largest angle. This is like then, okay. Then determine the largest angle through which end A may be rotated when a torque T is applied at section. Also find the value of torque, okay. So here what you have to find out, both the torque and the largest angle of twist that you have to find out.
Sir, the question like that here it is written as 54 mm steel core. So does it mean that it is the diameter or it is the radius?
Yes, it is actually the diameter, okay.
Sir,
Core means like we will be denoting like this as the core, okay,
sir,
and this is the, yeah, yes,
and 18 mm is the thickness only.
yes, 18 mm is the thickness. Actually this is like kind of core and cladding, okay. This is core, this is steel core, and this is like a clad, aluminum clad. So this is 54, and this is like 54 plus 18, which is 72 is the outer dia. Is everyone available on the call?
Yeah.
Yeah, okay. So first what we can find out, or first what we need to find out,
Relation between the sharing of the torque between these two.
yes. So in order to solve these kinds of problem, like this is a case of torque in parallel, for example, I mean shaft in parallel. For example, you when you are viewing it from the this side, front side, let us imagine this as the front side, okay. So this will be something like this, okay. Okay, and this is subjected to a single torque T. And this T, if we are writing, T is equals to T steel plus T aluminum. Okay, and what is the compatibility condition here with respect to angle of twist?
Same angle of
Yeah,
twist.
so theta steel must be equal to theta aluminum. So this is how you will solve the problem of shafts in parallel. So first I will this is the first equation and this is the second equation. I will try to, for example, T is unknown here. So only thing I know is T steel theta steel equals to angle of twist in steel section equals to angle of twist in aluminum section. Okay. So I have to find out what is the relation between torque, which is the steel, how much amount of torque that is beared by the steel and how much amount of torque that is beared by the aluminum. Okay. So T steel equal into L steel. Okay, here the length is 2.5 meter. So TS into L, since L is constant, I'm taking common L. Okay, and G steel into GJ. Okay, J of steel, which is equals to T aluminum into L divided by G aluminum into J aluminum. Okay, so when I substitute, 1 minute, I will drink some water. Okay, so where I have left, yeah, Ts into what is the length, 2.5 into 10 to the power of 3 divided by G value is 80 gigapascal, so into 10 to the power of 3 megapascal into what will be the core, it will be pi by 32 into d power 4, d is 54 the whole power 4. Okay, this should be equal to T aluminum into at last find out the relation between Ts and TL. Okay, I mean L we can cancel it out. Okay, divided by G is 27 into
2.266 of TS.
2.266. No, the relation what I am having here is like TS equals to 1.3715 TA. Okay, so here it is pi by 32. What is d power 4? 72 the whole power 4 minus 54 the whole power 4. Okay, sorry. So if I solve this, I should get this relation. This is 37.
Sir, why it is 72 to the power 4? It must be 90 to the power 4, sir.
No, 18 mm is the aluminum jacket. I said like the thickness is 18 mm. Okay, actually it is, yeah, it is 72 mm. 72 mm.
सर 90 होना चाहिए ना?
No. Actually, this whole jacket they have mentioned it as 18 mm. Okay, sorry.
सर
This
ये तो बहुत कंफ्यूजिंग है सर ऐसे.
okay. Actually, they have given an 18 mm aluminum jacket, right? So it should be divided by 2. Okay, so it should be 72 only. Please correct it. At the start, I have said it wrongly. Sorry.
बट सर ये तो एम्बिग्यूटी है ना.
Yes. See, based on, if there is some ambiguity, they will be mentioning the diagram as well. Okay.
Okay, sir.
Yeah, they will be mentioning this outer dia. So this actually is given in the question.
Okay.
Yeah. I think so only you have got a definite answer. Yeah. So the relation you are getting is this, right?
1.3714.
Yeah. What about others? Are you solving this problem or?
Yes, sir.
Yeah.
Getting that calculation.
Yeah. Okay. Thank you. So after this, when we substitute in this first equation, okay, so we will be getting like T aluminum equals to 0.422 of T, okay, and T steel equals to 0.578 of T, okay. Yeah. Solve this 1 minute. My class there. Okay. Yeah. Sorry. So is this fine? After this, you will substitute this equation here, okay, in 1. Okay, and then you will be getting T aluminum in terms of T and T steel in terms of T. Okay. And from this, they have given the allowable shear stress, right? So based on that allowable shear stress, you will be finding out what is the value of T. Okay.
Okay.
Yeah. So permissible stress is equal in steel is what? 60 megapascal. And permissible stress in aluminum is what? 45 megapascal. Okay. So whichever gives the whichever is not violating the other shear stress condition, that you have to take. Okay. So first I am taking Ts, which is tau s into pi by 16 d cube. Okay. Which is implies like Ts equals to 60 into 5 by 16, 54 the whole cube. Okay. And from here I am getting Ts value as 1.855 into 10 to the power of 6 Newton mm. Is this fine?
Yes, sir.
Everybody is getting this answer?
And T aluminium is 2.51, 2.251, 2.254.
T aluminum.
Yes, sir.
Please check your answer.
No, sir. 100 into 10 power 6.
Yeah, it should be 1.354 into 10 power 6. Okay.
Okay.
Yeah. See, now we have got the value of T. Okay. So when we are, what is the value of aluminum? We have got T aluminum is equals to 0.422 of T. Okay. So first I have to find out what is the T value. Only Ts we have found out. Okay. So what is the value of T? Like 0.578 of T is equals to Ts. Okay. So 0.578 of T equals to Ts, which is 1.855 into 10 to the power of 6. From this I will be getting what is the total value of T, which is 3.209 into 10 to the power of 6 Newton mm. Okay.
Sir, by compatibility equation of
Hmm.
T aluminium, I am getting 2.254, sir.
Okay, that's what. See, when you are getting the compatibility condition of aluminum as how much you said?
2.254.
2.254. Okay, so instead of steel, you have done for aluminum, right?
Yes, sir.
So when you are substituting after that, you will be getting the value of T, right? The total torque T. by substituting T aluminum, what you have got?
Sir, T aluminium is 2.254 maximum.
2.254. Yeah. So from this you will be getting what is the total value of T. Okay, which in this case would be like 0.422 into T equals to, for example, let's do your thing separately. Okay. So 0.422 of T equals to how much value you got? 2.254. Is it correct, right?
Yes, sir.
Yeah. So from this, how much value of T you are getting? 2.254 divided by 0.422.
5.341.
Yes, 5.341. So, but this exceeds the permissible stress of steel.
Yes, sir.
So, the other way you have to proceed.
Okay.
Yeah. Then, if that is the case, then this is violating, this is above 60 megapascal, right? When you are substituting this value.
Yes, sir. Yes, sir. Okay.
Yeah, so the opposite case you have to do. Then you have to first find out the maximum stress for the allowable torque for steel by the maximum shear stress of steel section. Okay, and then you have to come in the reverse direction.
Sir,
Okay,
sir,
sir.
sir
Yeah,
please mm,
repeat.
repeat one second.
Yeah, okay. See, for example, what I have done is like first I have taken what is the allowable stress of steel. Okay, for example, these two different allowable stress they have given for different materials. Okay, so first what I have done is like first I have taken the steel section. Okay, and then I have taken the allowable stress for the steel section as 60 megapascal, and then I have found out what is the torque which is to be sustained by the steel, which is 1.855 into 10 to the power of 6 Newton meter, Newton mm. This is the maximum torque that can be sustained by the steel section. Okay, so from this, if I calculate the total torque, okay, it turns out to be 3.209 into 10 to the power of 6 Newton mm. Okay.
Yes, sir.
Yeah, so if I substitute this total torque to this aluminum section, okay, for example, tau aluminum into pi by, uh, uh, for example, this is what to say, circular, hollow circular shaft, right? So it should be tau into ZP, okay, so pi by 32 into D naught power 4 minus DI power 4 divided by D naught by 2, okay, so it will be pi by 16 this divided by d naught. Okay, so when you are substituting this, and if you are finding for example here, uh, if you are putting the value of torque as 3.209 into 10 to the power of 6, and if you are finding out what is the tau aluminum, it should be less than 45 megapascal, then your answer is correct. Okay, otherwise you have to proceed in the reverse direction. So what the other person now has done is like, for example, instead of taking 60 megapascal, he has taken first 45 megapascal. I mean, for aluminum he has solved. Okay, so on solving the for aluminum section, he has got the T aluminum as 2.254 Newton, I mean into 10 to the power of 6 Newton mm. Okay, and with that he has got the torque value as 5.341, but the maximum torque which can be sustained by the steel section is what? 3.209 into 10 to the power of 6 Newton meter. So this actually violates, which means like the steel section will fail.
Okay, sir, got it.
Understanding, right?
Yeah.
Okay. So the maximum torque which the shaft is subject, or the composite shaft is subjected to, is equals to 3.209 into 10 to the power of 6 Newton mm. And here it is the torque of the steel section. Now separately I have to find out what is the torque sustained by the aluminum section, which is equals to 0.422 into T into 3.209 into 10 to the power of 6, which is equals to 1.354 into 10 to the power of 6 Newton mm. Okay, is it fine?
Yeah.
Yeah, so Now we have found out what is the value of torque. So the next thing what we have to find out, what is the value of theta. So can you find out based on this either theta s or theta a?
Stay.
Yeah, theta s here I am doing, okay. Theta s equals to t into ts into ls divided by ls common, so I will write it down, l divided by gs into js. So ts value you know, ls value I mean length of the shaft you know, and divided by g of I mean shear modulus of steel section into polar moment of inertia of steel section. What is the radian? How much radians you are getting? Anyone? You understood the problem, right?
Yes, sir.
Okay.
Sir, the calculation of the torque in the aluminum portion by the above formula
Yes,
2.25 into 10 power of 6.
that's what I have written it here. One person has said, right?
Yes, sir.
Yeah.
Actually, both are same. Why they are different?
No. See, this is not same with respect to this. Okay. For example, that's what I have told you before. Actually I have solved first for here I have solved for steel section, okay, but if you take the aluminum section and if you solve, then you will get T aluminum, the torque which is sustained by the aluminum section equals to 2.254 into 10 to the power of 6 Newton mm, okay, and based on this you will be getting the final torque as 5.345 into 5.341 into 10 to the power of 6 Newton mm. But the maximum torque the steel section can sustain is only 3.209. Okay, so this condition fails. So the maximum torque, so the design is to be based on the steel section and not the aluminum section. Okay, or still you have doubt?
Yes, sir.
Yeah, if you still have doubt, I will explain it again.
No, sir. Design based on the steel.
Yes, design is based on the steel because it can't sustain the torque. What we have designed based on aluminum.
The torque induced in the aluminum shaft is less than the steel.
Yeah, the torque in aluminum shaft is less than the steel shaft. Or else, like, see, first if you have taken the aluminum section, you have found out what is the value of the torque which is sustained by the aluminum section, and then you have found out what is the total torque based on the aluminum section, and then separately you are finding out what is the torque which can be sustained by the steel section, okay, and then based on that you are finding out the total torque, but this is 3.209, but the total torque which based on aluminum design is 5.341, which is way higher than the total design which is based on the steel section, okay, so we have to design based on the steel section alone.
Yes, sir. Angle of twist 0.069.
0.069. Oh, it should be 0.0506 radians. If you want, I will solve it here, okay. Theta s equals to, where is my mouse pointer? Yeah, theta s equals to, what is the value of ts? 1
No
point.
need, sir. I will check, sir.
Yeah, you will check, right, or should I have to do?
No, sir. I will check.
Okay, is this fine? Is everything clear with respect to this?
Yes,
Okay,
sir.
yeah. The time is 7:55. Okay. So this is based on indeterminate shaft. Okay. So read this problem and then definitely problem. What they have given is a horizontal shaft. Okay, 12 meter in length is fixed at ends. Okay. This is an horizontal shaft. (12 meter in length). Okay. It is fixed at its ends, and when viewed from its left end, okay, this side, when viewed from its left end, axial couples of 50 kilonewton meter clockwise direction. So when I'm viewing from this left side, it should be clockwise. So it should be something like this. Okay, at 5 meter, and in the next 9 meter from here, from the left end. Okay, so it should be like 4 meter away from here. I'm having another one twisting couple or an axial couple which is in the other direction. This is anti-clockwise, right? Yeah. So this is 75 kilonewton meter. This is a very different question. Okay, please try to solve this. So this can be named as section A, B, C and D. Okay, so determine the fixing end couple. So you have to determine what is the fixing end couple, or like TA and TD you have to find out, and then the position where the shaft suffers no angular twist, means you have to determine the point where theta or theta something equals to 0. Okay. So first what I will do here, we have seen in axial deformation also, right? In axial deformation what we will be doing for similar kind of problem?
Summation of the torque.
Summation of the torque, yeah. Summation of the torque equals to 0. This is the first equation. And the second equation? What is the second equation? What happened to others? Are they solving this problem? I don't know how many are, since it is the last class, so I don't know how many are available. Someone is raising hand, it seems. Wait, I will try to join from another account, okay? So that I will. So what will be the other compatibility condition here? Okay. Oh, only 3 people are there. Only 2 people are there. Sorry. Only 2 people are there.
3, sir.
3.
3 or 4, 4.
4 people. Okay, fine. Okay. So the other condition is like the compatibility condition. Like for example, in axial deformation, we will be finding out like del L of the total composite bar equals to 0, right? So this is the second equation, right? So similarly here, total theta, okay, the summation of theta should be equals to 0. Okay, the total angle of twist should be equals to 0.
Sir, why, sir?
Yeah, because because these two, yeah, this is like a kind of all these shafts are collected by a single entity and it is fixed at the ends. Okay, so what happens is like at the end you can't have any or what can we say, like there cannot be any separate angle of twist with respect to these fixed ends. Okay, meaning like the total angle of twist, which means like theta AB plus theta BC plus theta CD equals to 0. So that this at the ends you won't be having any angle of, it won't have a separate angle of twist. You are getting it right. So that's the
Yes.
meaning of fixed ends. Yeah. So this is the second equation. So when I write the first equation, for example, let's draw the free body diagram separately. Okay. So this is A. So here I'm having TA. Okay. So any direction you can take. Okay. Or sorry, not any direction. What I have told you in the axial deformation, can anyone remember what direction I have told you in the axial deformation? How to choose the reaction direction?
So in terms of clockwise or anti-clockwise?
Yes, in terms of clockwise or anti-clockwise. For example, whether, for example, in the reaction couple,
Yeah, it would be counterclockwise.
it should be counterclockwise. Why? For example, what the direction here I have drawn is correct or wrong?
Yes, sir.
If so, why?
Sir, CCW means also counterclockwise, no?
Yes, CCW is also counterclockwise. Yeah.
Yes, sir. Then it's 75 kilonewton is counterclockwise.
Yeah. Yes. So based on this, the the net torque is 25 kilonewton meter counterclockwise.
Yes.
So opposite to that you have to add. So it should be in the clockwise direction for at A, whereas for D it should be opposite to the direction of uh, the clockwise direction. For example, let's say instead of this we will be drawing like this. Okay, first due to this clockwise direction I will be having something like this, right, at B. Yeah, based on right hand thumb rule.
Yes, sir.
And then here I will be having something like this. Oh, sorry, should be like this. No, clockwise is like this, anti-clockwise is like this. See whether it should be towards the at point B, whether it should be towards the left or right, based on right hand thumb rule I'm asking.
So that would be left side, sir.
Left side, yes, the arrow should point towards the left side. Okay, because if I'm rotating in the clockwise direction, okay, my thumb is pointing towards the right. Okay, whereas for 75 kilonewton, if I'm rotating my right hand thumb or the right hand, my thumb is pointing towards the left direction. Okay, so this is 50 kilonewton and kilonewton meter, and this is C, which is 75 kilonewton meter. So the net reaction is towards this side. Okay, so opposite to that I have to add the reaction couples.
Yes.
Like this only we have seen for axial loads. Correct or not?
Yes.
Yes, sir.
Yeah. So TA we have to determine and TD we have to determine. So if I write summation T equals to 0, TA, okay, TA I am taking it as positive. So TA plus TD, because it is compression, okay, or pointing towards the cross section. So it is positive. And so, no, sorry. Here for the summation T and all, you will be looking only at the direction, okay, not the sign convention. For example, if I am taking this direction as the positive, I will write it out TA, whichever arrow is pointing towards the right direction, I will write it as positive. Okay. Whereas for theta, I should go by sign convention. So TA plus TD and plus 50 minus 75 equals to 0. This is the first equation. And the second equation is based on the total angle of twist, which is theta AB plus theta BC plus theta CD equals to 0. Okay. So if I write it, what it will become? What is theta AB? TA into LAB divided by G and J are constant, right? Yes or not? G and
Yes,
J,
sir.
yeah.
Yes.
So theta TA. And what will be the torque acting on section BC? Whether it's positive or negative.
Sir, please repeat it again. What would be the positive or negative? Are you asking?
Why I'm asking here is, see, for cross section, I mean for finding out theta AB, you have to follow the sign convention. For finding out the angle of twist, you have to follow the sign convention. Only then you can get whether the theta is towards the clockwise direction or towards the opposite direction. Okay. So based on that only, this total equation will become 0. Otherwise, it won't become 0 if you are not taking the sign convention. But whereas for the summation t, you can, based on the direction alone. For example, if the start at the start I am fixing like towards the right, I am taking it as positive. That's all. I can take it like that. Okay.
Yes.
Yeah. So here you can find out in this section AB only theta A is acting, and that is towards the cross section. So it is positive. Whereas for theta BC, how much I will write? What is the torque acting on BC section?
TBLBC and
See, this is torque TA plus this 50 will act towards the right direction. 50 is acting towards this right direction. So if you are drawing the free body diagram of BC section alone, okay, towards this you are having TA plus 50, and that will be balanced by the opposite side, right or not? Not.
Yes, sir.
yes, sir.
Okay, so and TA plus 50 is pointing towards the cross section, so I am writing it as positive direction into LBC divided by GJ plus theta CD. What will be the torque acting on theta CD? In terms of TA itself, you can write, so that ultimately we will be from this equation we will be getting what will be the value of TA. Okay, so how much it will be? TA, for example, if you are drawing the free body diagram of CD section, it will be TA towards this direction plus 50 towards this direction, but minus 75 because it is pointing away from the cross section. Okay, so the net load which is acting is TA minus 25. Correct or not?
Yes, sir.
Yeah. So it is TA minus 25 into LCD divided by GJ equals to 0. So GJ, if it goes the other side, it will become 0. So only TA into, based on lengths we can calculate. Okay. So what is the length of the section AB?
5 minutes.
5. Yeah. Plus TA plus 50 into, what is the length of BC? It is 4. Plus, what is the length of CD? It is 3 equals to 0. Okay. From this, what can you calculate? What is TA value? What is the value of TA you are getting?
Solving.
Yeah.
$22.2.
22. Are you getting 22?
31.
31. No. Okay, let's solve. Okay.
31.
No, I'm getting like 10.42 minus 10.42. Okay, let's solve. 5.
Yeah. I made a mistake. Let me see.
Yeah.
But 10 not 15.62.
Okay, let's see. 5 TA plus 4 TA plus 3 TA, right? All the TAs have combined. Plus 200 minus 75 equals to 0. Correct? From this, 12 TA equals to minus 125. So what will be value of TA?
10.41.
Yeah, 10.41. So it should be minus 10.42 Newton meter. Okay?
Yes.
Yeah. So once we have found out what is this minus sign actually indicates. I have got the value of TA as minus 10.42 Newton meter. Sorry, kilonewton meter. Okay. So what is this minus sign indicates?
Opposite direction.
Yes, the assumed direction is not the correct direction. It is in the opposite direction. So after finding out TD, for example, minus 10.42, okay, on solving this TA, okay, TA I have to substitute in the first equation. Here I have to substitute TA, and if I'm substituting minus 10.42 plus 50 minus 75 plus TD equals to 0. And what is the value of TD I'm getting here?
$35.5.
35?
35.
Yeah, 35.42 kilonewton meter. Okay, so this is positive, the other one is negative. So when drawing the free body diagram, okay, I will be having something like this. It is in the opposite direction, TA. TA we have assumed it like this, so it should be like this, 10.42. And here it should be 50 in the right side, and then here 75 in the left side, 75 kilonewton meter, and here it is towards this side, 35.42 kilonewton meter. Here it is 50 kilonewton meter. Okay, so can you find out now what will be the angle of twist C? See, now what is the question they have asked now? Now we have found out what is the fixing end couple, right? TA and TDs are found. And the position where the shaft suffers no angular twist, that we have to find out, okay? So for that, what we will do? Any idea?
So by using polar moment of inertia, we get
Yes, by using polar moment of inertia. But how we will find out the angle of, I mean, the position where the shaft suffers no angular twist? Okay, let me say. See, for example, first you have to find out what is the angle of twist of B with respect to A, which means you have to find out what is theta AB. Okay, and you have to see whether it is negative sign or positive sign. Okay, and then you have to find out what is the relative angle of twist C. Okay, with respect to A. Okay, and see whether it is positive or negative, and then you can find out, for example, if it turns out to be positive, then you can somewhere say like between like these two sections I'm having the position of 0 angle of shift. Okay, let me make it clear. Okay, first I want to find out what is the angle of twist of theta BA, or the angle of twist at B with respect to A. Okay, yeah, theta BA, which is angle of twist of B with respect to A. So A is actually 0. Okay, so it will be theta B. Okay, so what is theta B actually? How we can find out? It is T into L divided by G into J. So what is T here? It should be 10.4, and it is pointing away from the cross section. So it should be minus 10.42 into what else? L, the distance here 5 meters. So 5 meters. So here I will substitute in meters. Here it is in kilonewton. So here I should write it as 10 to the power of 3. And here the denominator G. What is the value of G they have given? Oh, G they have given, right? Yeah. So whether G is needed here or not. Anyway, we are going to find out what is the position where like theta is 0, right? So here G or J is not needed. Okay.
Uh-huh.
Yeah. So directly I can, so instead of that, directly I can substitute in kilonewtons itself. Okay. So what value I will be getting here? Minus 52.10 divided by GJ radian. Okay. Now what I am finding out is like the angle of twist of CA, which is theta C minus theta A. So here A is equals to 0 since it's a fixed end. So theta C equals to the total net torque which is acting in section C, that we have to found out. Okay, so it is nothing but like here, for example, angle of twist at C is nothing but, how can I find out the angle of twist at C? With respect to D also I can find out, right? For example, this is the CD section. Okay, and here I'm having this as the torque, 35.42 Newton meters. Yes or not?
Yes, sir.
Yes.
Yeah. But this is pointing away from the section. So 1 minute. Here we have written since it's pointing towards the other direction. Okay, let's find out. Okay, so this is 10.42. Okay, and plus 50 minus 25, again it will be becoming like 35.42, which is acting away from the cross section, right? But how come? 1 minute, 1 minute. Okay, 10.42. See, 75 plus 10, 10.42 minus 50, which is 35.42, which is acting towards the opposite direction. So here also, what I'm thinking is like here also it is pointing away from the cross section, right? For CD,
Yes.
35.42 into what is the length here? It is 3, yeah, divided by G into J. So which will be equals to 106.26 divided by GJ radian. But here what they have done is like they have taken only positive value. Why not negative value? Here they have taken negative value, but whereas here they have taken positive value.
Sir, why it has taken positive value, right, sir?
Yeah, theta C they have taken it as positive value. How
Sir,
can we find out?
if we have we took negative value, then that seems like
It is rotating in same direction like that, huh?
Yes, sir. Or in failure, sir.
Mm, See, for example, let's imagine like this is pointing away from the cross section. Okay, so theta b will be in one direction, right? For example, let's say if it is pointing in the opposite direction, if I am twisting means, uh, okay, like this I'm twisting. So this will be in one direction, whereas this should be in the opposite direction. Mm, okay. Yeah, got it. See, for example, analyze this section AB. Okay, analyze this section AB. Okay, this section is having torque in this direction, right? Like this.
Yes,
This
sir.
is AB. Yeah. Analyze the
Mm.
section CD. This is having torque like this. The whole like what to say, like this, right? So these both of the things look identical. So in between, somewhere here, between B and C, we should have an opposite torque like this, right?
Yes, sir.
So that the final, for example, if I plot the, what to say, uh, this angle of twist, okay, C and D. Here I know the angle of twist at D and A are 0. Okay, here and then angle of twist at I mean B, it is negative. So what I will be doing is like I will be drawing in the negative direction, and that is minus 52.10. Okay, and then like again here somewhere here it should be in the opposite direction. Okay, for example, it should be a positive value, and then somewhere between BC it should cross 0. This is positive, this is negative. Okay, see if these two are in, technically speaking, these two torques are in same direction, right?
Yes, sir.
Yeah, but from one end if you are looking it is in the other direction, and from the other end if you are looking it is in the other direction. That's it, that's the difference.
Yes,
Yeah,
sir.
that's the difference. Okay, so that only here we are giving a negative sign and here we are giving a positive sign. So in between B and C there exists a point of 0 angle of twist. Okay,
Yes,
Yes.
sir.
yeah. So we have to find out where the angle of twist lies. I mean point where angle of twist where 0 lies. Okay, so it will be theta AB plus theta BX, let's say. Okay, so theta AB is nothing but already we have calculated it is minus 10.42 into 5 divided by Gij, which is minus 52.10, which is equals to 0. Okay, so minus 52.10 divided by Gj plus, okay, for theta Bx what I have to do, it should be 50 minus 10.42, Correct or not? Yeah, because 50 is in this direction and 10.42 is in the other direction.
Other direction.
Yeah, multiplied by x. This x I have to find out. Okay, divided by gj equals to 0. Okay, so if I write this minus 52.10, gj will get cancelled. So 50x minus 10.42 x equals to 0. From this I will be getting what will be the answer of x. So what is the answer of x?
1.25.
1.25. Is it not 1.31? Let's see. Here I am doing minus 52.10 plus 50 minus 10.42. 39.58, right?
1.316.
Yeah, 1.31. 39.58x equals to 0. So 39x is equals to 52 divided by answer 1.316, right?
Yes, sir.
Yeah, 1.316 from B. So from the left end it should be 5 plus 1.31. So it should be 6.31 mm from point A or from end A. Okay?
Yes.
Yeah. So here I am winding up the torsion chapter. Okay?
Okay, sir. Thank you.
Yeah. So remaining half an hour is there. So I will go through what is needed in uh, thin cylinders and columns. Okay?
Sir,
Yeah. Yes.
in shafts connected in the series and connected in the parallel, what is the typical application like centrifugal pumps connected in the series or the high added centrifugal pumps connected in the parallel for more discharge like that?
No. That is not related. That is with respect to discharge. Okay. With respect to fluid mechanics, you are saying, right? And yeah,
Similar analogy,
yeah,
that
similar
typical
analogy.
application.
No, there you will be getting d to the power of 5 and all, right?
Yes, sir.
Yeah, so we can't make a similar analogy here. This is
Our
very
analogy,
uh,
typical application.
what?
Applications are not analogy.
Yes. Application, like based on there, we are actually discussing about pumps in series, pumps in parallel, but we will be having like same discharge and same head loss. Based on that, we have to calculate the diameter of the or the equivalent diameter of the what to say, a single pipe, something like that. We will be doing there. Yes.
Yes, sir.
Yeah. Okay. So here with first we will see what is thin cylinder and what is thin sphere. Okay, thin cylinder. With what we will say as thin cylinder, there are two cylinders like thick cylinder and another one is thin cylinder. Okay, the where the d by t ratio is greater than 20, greater than or equal to 20, we will say this as thin cylinder. Okay, and where the ratio is less than this, we will say that as thick cylinder. Less than 20, we will say that as thick cylinder. Okay, so with this like we are having why are we actually studying this thin cylinders or thin spheres, something like that, where it is used?
To carry the fluid medium.
Yes, to
I, I
to store a pressurized fluid. Okay, in order to store a pressurized fluid, we will be using a cylinder, okay, or a sphere. For example, storage tank can be in the form of sphere and a boiler can be in the form of a cylinder. Okay. So let's imagine here a boiler. Okay. This is a boiler which is covered at its ends by a hemisphere, okay, or it is a dished hemisphere, okay, something like it is fixed or it is closed at both these ends, okay. So in order to extend the length, for example, if I want another one length, actually these boilers are made by welded joints, okay. We will be welding to get the required joints. So in welding you would have studied, right, design of welding. Like in order to get this required length, we have to join these two lengths circumferentially, like we have to weld here, we have to make a weld here. So what is this circumferential joint which we are going to do, whether it's lap joint or butt joint? It's a lap joint, okay. In order to get the required length, we have to do a lap joint. So the in welding we are not getting 100% structural efficiency, okay. There might be some there might be some reduction in the structural member compared to the whole solid, okay. So here we are getting the efficiency of circumferential joint, okay. And with respect to a given diameter, for example, if I want a more diameter, then I have to join the diameters in terms of butt joint, okay, and these are termed as longitudinal joint, okay. This I am doing it circumferentially in order to get the required length, and this I am doing it longitudinally in order to get the required diameter. This is butt joint or longitudinal joint. Butt is kind of weld, the joint we can term it as longitudinal joint, okay, which I am naming it as eta longitudinal, LJ, okay. Yeah, up to this it is clear?
Yes, sir.
Yeah. So if I want to find out what will be the for example, inside this pressurized fluid is there, okay, which is exerting a pressure in all directions, okay. Imagine like this is a cylinder, so you should not imagine only which pressure is acting towards this direction, but also circumferentially, okay, towards this, towards this, towards this, towards this, and all through the circumference it is acting, okay. That's the point I want to make. For example, if I like this, it acts, okay, and you are having a thin section like this, which is of thickness T, okay, and D is kind of diameter, okay. So here what I will be doing is like this diameter, I mean the outer diameter D, okay. So due to this pressure, what happens is like this whole boiler tends to break longitudinally as well as circumferentially, okay. Why? Because of this pressure which is acting inside due to the pressurized fluid, okay, which is greater than the atmosphere. The pressure inside is greater than the atmospheric pressure, okay. Due to this, what happens is like you will be getting both circumferential stress as well as the longitudinal stress, okay. Towards this also you will be getting a stress, and towards the circumferential also you will be having one stress, okay. So we have to find out those stresses. So what I will do is like I will take a section of this, okay. Okay, so towards this the pressure is acting, and you will be having resisting force by only with this area, okay. This is along the longitudinal direction. Along the longitudinal direction, pressure is acting towards this direction, and you are having resisting forces towards this direction. So what will be the pressure into pi by 4 d square? That is the total force which is acting in the x direction. Let's name this as the x direction, okay. So P into pi by 4 d square, which will be equals to the resisting force, okay. The resisting force, how can I write? The longitudinal stress, okay, into the area. What is the area? Area here, let's say this is thickness T and diameter D. What is the area here I will take? Pi dt, okay? Yeah, pi d into the thickness T, okay? So sigma L ultimately it turns out to be PD divided by 4T, okay, where P is the internal pressure which is above the atmospheric pressure, okay?
Sir, pi d square t or dt?
Pi by 4, pi dt only.
Okay, okay.
Because circumferential is pi d multiplied by its thickness. Yeah. Okay. So, and d is the diameter of the shell and t is the thickness of the shell. Okay. So, this is called longitudinal stress. Okay. And there is another one thing called circumferential stress or hoop stress. Okay. So here if I want to calculate in terms of, for example, if they have given the efficiency of both the longitudinal joint as well as the circumferential joint, if they have given, then this formula will be replaced by what? Efficiency of longitudinal joint or efficiency of circumferential joint? Circumferential joint, yes, because that is the thing which is holding towards the circumference, right? We are actually getting the required length by having the circumferential joints. Okay, so whether it should be multiplied by circumferential joint or divided by circumferential joint. See, if I am multiplying this by circumferential joint, then the value of longitudinal stress what I will be getting is less. So that means like I am undermining the efficiency of circumferential joint. So I should divide this. Okay.
Yes.
Yeah. So similar to that, if I am finding out what is the hoop stress, okay, I will copy this down or should I have to wait?
Copying it down.
Okay.
Dance.
Done? Yeah. So when I'm finding out what is the hoop stress, okay, in order to find out the hoop stress, it is along the circumference, right? So it is something like this. Okay, it is something like this. Here pressure is acting in all directions and only the resisting area is this. Okay, and this length is L, thickness is T. Okay, so what will be when we are carrying out the force balance, what we will be having? For example, pressure is taken based on the projected area. Let's say this is the projected area. Okay, so this will be P into L into D, which is equals to, you are having two areas here, so it will be 2 times of 2 into L into T into sigma hoop stress. So sigma hoop you will be getting as, sorry, L into T is the time, so only one L will come. Yeah, L into T is the area, so 2 times of L will be the total area. Okay, it should be like this. So it will be PD by 2T, and the joint efficiency, if I take into account, it will be PD by 2T into eta longitudinal joint. Okay. Okay.
Yes, sir.
Yeah. So for thin spherical vessel, okay, SPV. For thin spherical vessel, you will be having only single value of hoop stress, because In all the things, the dimension is the same. Okay, it is nothing but the diameter. Okay, here we are in, for a cylinder we are getting length as well as the diameter. Okay, length as well as diameter, but here you will be having only diameter, so only one hoop stress you will be getting, which is acting along the circumference. So for thin spherical vessel it will be PD by 40. Okay.
Yes.
Yeah, in all these cases sigma 3 equals to 0. Okay, for here also sigma 3 equals to 0. Sigma 3 is nothing but the principal stress. Okay, here sigma 1, what will be the value of sigma 1, whether it will be hoop stress or longitudinal stress for thin cylindrical shell?
For cylindrical cell, it would be longitudinal.
Yeah, no, for cylindrical sigma 1 is always the greater value, right? So it should be hoop. Yeah, and
It would be
sigma 2
hoop.
will be, yeah, longitudinal
As
stress.
as
Okay,
as
whereas
circumferential stress would be the greater than the
yes,
hoop.
yes. So here sigma 1 equals to sigma 2 equals to sigma hoop. Okay, so based on this you can calculate what is the absolute tau max I am getting for cylindrical shell, something like that, or maximum tau max in plane, like that, something like that you can actually find out. Okay, yeah. So based on this we will do one small problem. Okay, do you want to copy this? I will wait. Once
Done.
you have done copying you can say done.
Done.
Yeah.
Mhm.
What about others? I couldn't get any feedback from others.
So can you go back 1 second?
Yeah.
Okay, so done.
So here in this question, I'm having a cylindrical shell like this, okay, of diameter d and length L. Okay, this is a cylindrical shell, and inside this a pressurized fluid is flowing, which is having a pressure of P, and I want to give a force F, okay, in the axial direction, okay, and I want to find out what will be the value of this force F in order to obtain pure shear state of stress. How can I find out this? Yes, how can I find out this? Any idea? See, due to this pressure vessel alone, what stresses are you getting?
Hoop stress.
Hoop stress and longitudinal stress, right? So longitudinal stress is towards the this direction and hoop stress is towards the circumferential direction.
Mhm.
Yeah. So this one is actually sigma 1 and this one is actually sigma 2, right or not? Yeah. Plus, what is the other stress which I'm giving in the axial direction? It is due to F, and that is a compressive stress. Okay, so if I'm combining this, what system I will be getting is like P combined with F. I will be getting something like this: sigma L minus sigma A, which is equals to sigma 2, and this will be sigma H, correct or not, which is equals to sigma 1, the major principal stress, and this is the minor principal stress. Okay, are you following?
Yes.
Yeah.
Yes, sir.
So to obtain pure state of shear, what is the condition? Anyone? To obtain pure shear state, what is the condition in terms of principal stresses? For biaxial, you can say this is a biaxial case, right? So if you draw the Mohr circle, it should be pure shear. Okay. So sigma 1 equals to sigma 2, but it should be minus of sigma 2. Correct or not?
Mm-hmm.
Okay. So
As it
sigma,
is rotating.
yeah, sigma 1 should be equals to minus of sigma 2. Correct or not?
Correct, sir.
Yeah.
As it is rotating.
So sigma h equals to minus of sigma L
Sigma.
minus, yeah, sigma A. So what is sigma h plus sigma L equals to sigma A? What is sigma h plus sigma L? PD by 2t plus PD by 4t equals to sigma A is nothing but F divided by, what is the area here which I have to take?
So as it is pi dt.
Good.
Pi dt.
Yeah, pi dt. So based on this, I will be getting the final value of F. What is the final value of F?
Pi rho d square t by pi rho d square into pi rho d square by 2
Pi p d
rho
square,
d
not
square
is
by 2.
that is not d rho, it is d
Oh
p
yeah.
p. Pi p d square into 3 by 4.
3.
Correct?
Yes, sir.
Yeah. So shall I proceed to columns then? Okay. I'm assuming everyone has copied this. So let's see about columns. Okay. What is the difference between a column and a beam? We have already spoken this, right? A column is a long beam, okay, whose length is higher than the cross-sectional dimensions. Cross-section dimensions. Okay, so when I am applying a load here, what happens is like it will buckle. Buckle means what? It will elastically deform. So that is also a kind of failure. Okay, we don't want the column to buckle elastically. It won't fail at all. But what I am saying is like it will elastically deform. Okay, so the stress induced or the buckling stress induced is less than the proportional limit or the elastic limit. Okay, is everyone there? I couldn't get any response.
Yeah. Please repeat it. Repeat once it again.
Yes, sir.
Yes, okay. See, for example, this due to a load W, okay, what happens is like this long column will buckle elastically because of its length being greater than its cross-sectional dimensions due to the axial compressive load. Okay, what happens is like it will buckle without failure. Buckle means it will elastically bend, and on removing the load it will regain its original shape. But this elastic buckling we don't need. So this elastic stress which is induced is less than the proportional limit. This is the thing which I am saying here.
Okay, sir. Thank you.
Yeah.
Sir.
So if you want to calculate the buckling load, it is given by PE. PE is the buckling load. Okay, PE, which is equals to pi square E I minimum, okay, divided by L E square, or it is given by N pi square E I min divided by L square. Okay, where I min is the minimum of Ixx and Iyy. Okay, and E is the Young's modulus. And L is the length of the beam, length of the column. Okay, here you will write it as column. And what is LE? LE is the effective length, and LE is given by alpha into L square, or alpha into L, sorry, alpha into L, where alpha is known as the length fixity coefficient. Please note down soon. Okay, length fixity coefficient. And alpha can be related to n by n is equals to n. This is n. N is equals to 1 by alpha square. And n is known as end fixity coefficient. End fixity coefficient. Okay?
Okay, sir.
Yeah. So the assumptions here we are making is like the load is truly axial and crushing is neglected. Actually, what is crushing is like it will fail due to when the stress is greater than the yield stress in compression. Okay, that is termed as crushing. Here we are assuming like crushing does not happen, and then the length of the column is large compared to its cross-sectional dimensions. Okay.
Okay.
So yeah, so based on this we will be having 4 table. Okay, this table is very important. Here I will write the end conditions. Okay, end conditions, and here I will be dotting out the alpha value and n value, n, and this is alpha. Okay, n is equals to 1 by alpha square. Okay, we will be having 4 sections, 1, 2, 3, 4. Okay, so here the first condition is like both ends fixed. You have a long column with both ends fixed, and for this the value of alpha will be 1 by 2. And what will be the value of n?
4.
4. Yeah, and the other thing is like one end fixed and another one hinged, and for this the alpha value is 1 by root 2, and here you will be having 2. And for this both ends hinged, if the column is both ends hinged, you will be having alpha as 1 and n as 1. And if the column is one end fixed and another one is n is free, then you will be having alpha as 2 and this has 0.25. Okay,
So here, what is n, sir?
n is known as n fixity coefficient. Based on
Okay.
yeah, based on different n conditions, these n and alpha values will change.
Okay, sir.
Yeah. So based on this, we can come up with some kind of objective problems also. For example, how much of buckling load in, for example, can you say how much of buckling load in with both ends fixed will be x times of, like for example, a buckling load to both ends fixed and free. Can you find out what will be the value of x if all the other conditions remains the same? Can anyone say this? Yeah.
So please solve the engineering problem.
So here P is directly proportional to N. PE, the buckling load is directly proportional to N. So PE for both sides fixed divided by PE for both sides fixed and free, which will be equal to N of both sides fixed divided by N of both sides free and fixed. Okay. So if I am writing it down, PE divided, both sides fixed divided by PE fixed and free, which is equals to what is both sides free? Fixed it is 4, and for fixed and free it is 0.25. So 4 divided by 0.25, it will be what? 16. So PE of both sides fixed will be equals to 16 times PE of fixed and free. So therefore x is equals to 16. Okay. Then there is a term called slenderness ratio. Okay, it is used to compare the buckling loads made of different columns but made of same material and same area. Okay, slenderness ratio denoted by S. Slenderness ratio, which is equals to LE divided by K, where K is equals to root of I minimum of Ixx and Iyy divided by area of the cross section A. Okay. This slenderness ratio is used to compare buckling loads made of for different columns made of same material and same area. Okay, that's the significance of slenderness ratio. So for
So here,
yeah.
so here really and can you explain, sir? How can you take?
Okay, that I will explain. Yeah, sure. See, for example, buckling load is PE, correct? So if I want to find out the buckling stress, which is sigma E, okay, which is the buckling stress, which will be equal to PE divided by cross-sectional area of the column A, correct or not?
Yes, sir.
Yeah, so which is equals to what is the buckling load here? Pi into pi square E into I min divided by LE square into A, correct?
Okay, sir.
Yeah, here LE is the effective length, which is equals to alpha into L. LE equals to alpha into L. Okay. So I'm rearranging these terms in such a way like I can write it in terms of yes, slenderness ratio. LE square and I min by A, I can take it in the numerator. Correct or not? So this I can rewrite it as pi square E. I min by A is nothing but K square, which is K is nothing but radius of gyration. Okay. So sorry. It is a term which is I min by A. Okay. I don't know whether it's equal to radius of gyration. Okay. LE square. And if I rewrite this, it will be pi square E by LE square divided by K square, which is equals to pi square E divided by S square. So therefore, buckling stress equals to pi square E divided by S square, where S is the slenderness ratio. Okay?
Sir, here how K square is going to means how is a area is going to numerator, sir?
Yeah, that is a constant which we are assuming. Okay, based on I minimum moment of inertia divided by the cross sectional area. If we are taking under root, this is a geometric property which is equals to K, like that.
Okay, sir.
Okay, so that is that K is related to slenderness ratio. Okay, so based on this, what we can write it down is like, for example, if a column is given which is made of same material and cross-sectional area, then we can write sigma E is directly proportional to, inversely proportional to 1 by S square. Okay. So if the slenderness ratio increases, the buckling stress, what will happen?
Yes, sir.
If the slenderness ratio increases, what will happen to the buckling stress or the buckling load?
Decrease.
Decreases. Yes. So if the buckling load or the buckling stress decreases, then it will fail at a very small load. Okay. So we have to design the column in such a way that it has a slight value, I mean a very low value of slenderness ratio. Okay. Yeah. So shall we do one problem based on this, and we will wind up. Okay.
Okay, sir.
Yeah. So you have a column, okay, which is hinged on both sides, and this is subjected to heating. Okay, we are heating all over, so that the temperature rises delta T. Okay, or delta T can be delta T. Okay, the temperature rises delta T. So due to this temperature rise, there exists a buckling phenomenon. Okay. So you need to find out when it or what is the condition for the or what we can say, what is the condition for the buckling tendency to happen when the temperature is rising. Okay. What is the buckling load for this? You imagine this as a cross-sectional, I mean circular section. Okay, so P is what? Pi square E I min. I min is like pi by 64 d power 4. Correct or not? Into L square. And n value is nothing but, what is the value of n for both ends hinge? It is 1, right? Yes or not?
Yes, sir.
Yeah, so it will be pi cube e d power 4 divided by 64 L square. Okay, this is the critical buckling load. If the force due to the temperature rise, okay, if the force due to the temperature rise is greater than this buckling load, then this column will buckle and it will fail. Okay, so that is the condition for buckling. Okay, so what is this force due to this temperature rise? We have learnt it in thermal stresses, right? With both ends constrained, we have uh, noted down the reaction force, right? Alpha TEA. Correct or not? Compressive stress, thermal stress will be alpha TE multiplied by the area of cross section will give the reaction force alpha TEA. Okay, so if this alpha TEA is greater than this pi cube E d power 4 divided by L square, then buckling will happen. Okay, so we need to find out what is the temperature rise delta T. Okay, so keeping T this side, I will take the other things. Okay, and to A also I will substitute. Okay, E gets cancelled, and alpha is remaining, and pi by 4 d square. Okay, greater than pi cube d power 4 divided by L square. So on simplification, it will become T should be greater than pi square d square divided by 16 alpha L square. Okay, so this is the condition for buckling to happen. Okay.
Yes, sir.
Yeah, so I am closing here, and it's been a good journey all through this days. Okay, all the best for your gate exam. Prepare well and do your exam well. Okay, all the best.
Thank you, sir. Many
Thank you,
thanks.
sir.
Yeah, thank you, thank you.
Okay.
Hope we will get you on the. If we didn't crack, then we might get you on the phase 3 as well.
Yes, yes, sure, 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 sure.
Thank you, sir. Many thanks.
Thank you, thank you.
So next week no class, sir, yours?
Yes,
next week your class
Actually, they told
is
like
not
today
there,
is
sir.
the yes. Next week we won't be having any class. That's it. We are winding up. Okay.
Okay, okay. Thank you so
Yeah,
much, sir.
I heard like that only. Okay, from the NPTL people.
Okay,
Okay.
sir. Your lecture is very good, sir.
Okay.
Thank
Thank
you
you.
for your support, sir.
Thank you. Thank you.
Okay, sir. Sir,
Yes.
have you stopped the recording? Then I have some queries.
Okay. 1 minute.